Hopefully you can hear us online. Okay, thanks very much for joining our Christmas session for the London section. Thank you very much for the RSSB for hosting us here and allow us to use their facilities. Thanks to Mike for getting us mince pies. I'm sure those of you online can have some kind of a treat as well.
Oh, Dominic got some as well.
Oh,
Yeah,
as well.
it's not just the brain booking you get with the RSSB.
I'll remember that.
Get a few mince pies in as well.
Every service possible. Right, thanks, RSB. One of minor. There's a voice like that. Tom thing. Tom's still on sound. Right. Don't think I can hear myself now. So, excellent. All right. Toilets out of the door on the left-hand side as we came in. No fire alarms expected. So if there's a fire alarm, follow the signs and get out. From national business next year, 2 seminars currently definitely penciled in, more to be announced, but first one in March on resiliency in rail. Very similar subject. Sure somebody will be suddenly coming along, Tom, if there's any vacancies in that, gaps in that agenda. And another one in May is Railways in Ireland, held in Ireland. But how many of you want to go on a quick holiday trip?
Yeah, volunteer going to that. It's going to be a good one. It's in Dublin.
Yes.
Yes.
Okay. So, very welcome to, I'm glad to introduce Tom, one of our former chairmen, who's now looking after a bit of railway in the southeast, the Network Rail, and he's going to talk to us about infrastructure resilience and hopefully a bit about his infrastructure as well that he's been looking after.
Yes, we've got plenty of scary posts. I'll keep you in suspense for those. Thank you, Mike, and yeah, welcome everyone to the RSSB. Welcome everyone online. Thank you for having me. So, I've been thinking about this talk for a while. I think it's a really interesting subject, and it's really a big challenge for the industry. I kind of want to pose more questions than answers, and I'm quite keen to hear all your views on this. So it obviously means a lot of different things to different people. There's a question I want to pose, and I'm hoping I'll be able to inspire some debate from you all. So please feel free to ask questions at the end, and hopefully we can have a good discussion about it. So just to introduce myself, first of all, so I graduated from Imperial College London in 2012, so I did a civil engineering degree. I then joined London Underground straight from university. I did the civils graduate scheme, where I worked with many of you in the audience, which was good. At the end of my 3-year scheme, I got introduced to maintenance, so thank you to Delif and Tom Kiley, I don't know if you're on for that, give me a really good introduction. And that's where I decided I really like to have a career in maintenance. So I started off working for the Tampa manager, Michael Hayes, and I went on to be the assistant track manager of the district line, or SSL South as it was known, which is basically the south of the Circle Line and the whole of the district line. That was up until very recently. To kind of vary my experience, I then decided to join Network Rail in 2022. So I'm currently the infrastructure maintenance engineer of Orpington. So I manage 2 TMEs, an STME, and various other managers who look after all the infrastructure. So my patch stretches from just south of Brixton, so very urban, to Hastings on the coast. So there's a real variety of infrastructure, a variety of challenges, which I'll go on to talk about. So what I'd really like to talk about tonight is, first of all, what is infrastructure resilience? Can we define it? What do we really mean by it? What are the key challenges in it? I'd then like to talk about a lot more about the challenges we're going to face. So we obviously live in a very changing world, and there are lots of things we know about, and there are a few unknowns as well, which I'll go on to talk about. Don Rumsfeld, there's known knowns and unknown unknowns. I'll then touch upon potential solutions, and the question I really want to pose is, are we doing enough now to ensure that future generations will have a railway fit to these challenges? So we live in a very changing world, do we know enough now, and are we doing enough now to make sure that the railway, the current standard railway we all enjoy now, is going to be available for future generations? And can we improve it? That's what we really should be doing in maintenance and in railway in general, is looking for continuous improvement, not just keeping things at the level they are, because that in the long term doesn't work, which I'll go on to discuss. So just some definitions, first of all. So I'm sure everyone in the room and everyone online knows what we mean by infrastructure. So it's really important we think fence line to fence line now, particularly in the modern railway. So key note here is that everything is interrelated, and that how you maintain one asset has a really big effect on how you maintain another one. So the classic one is drainage. So Network Rail in general has done a really poor job in maintaining drainage, which in historically, so in the 80s, they disbanded a lot of the drainage gangs, and that's had a really big effect on how they've had to manage earthworks and how they've managed track quality over the years. So we are now seeing a real renaissance in how we manage off track. We are building our own off track organisation in Kent at the moment to focus on that. And we have had a real upscaling in the drainage gangs we've had, which has led to us finding a lot of drainage we didn't even know about. It's not on any maps. So it is really, that is a really key asset. Earthworks as well is one of the big challenges we've had. So a lot of these have very kind of ambitious slope angles that were built by navvies with spades in the Victorian era. And to be honest, they haven't really changed a lot since. It's a real challenge to maintain them now, and there are lots of changing conditions, which is making it more and more difficult to do. Another one that's really kind of made the headlines recently is OLE. So I'm sure you all saw in the news about the failure on Crossrail. That's obviously had a really big effect on the railway in the public sphere, and it delayed and stopped trains for over 3 hours. So the key here really is to try and think as the railway as a system rather than just managing it asset by asset. So thinking about things from an infrastructure perspective rather than just an asset perspective is going to be the key to success. So what do we mean by resilience? Well, as you can see, resilience means many different things to many different people. So the definition of resilience in the dictionary is the capacity to withstand or to recover quickly from difficulties, in effect, toughness. Now, in infrastructure and in infrastructure management, we are very, very good at trying to redefine that. So in the 2007 flooding report, Sir Michael Pitt defined resilience as the ability of a system or organisation to withstand and recover from adversity. As such, a resilient organisation is one that is still able to achieve its core objectives in the face of adversity and for a combination of measures. The UK government, in current infrastructure, defines it as activity to prevent, protect and prepare for natural hazards. There's another definition, which I got online, which is resilience to infrastructure may be interpreted simply as robustness of a structure to withstand hazards. However, this introduction sets out and explains a number of interfaces which narrow definition could conflict with or miss opportunities to reinforce wider resilience within infrastructure systems. So I think the key to understand here is it means lots of different things to lots of different people. So as a customer on a train with resilience, you're really worried about whether the service can run when there's problems and you can get home in the least amount of time. To infrastructure management companies like Network Rail, London Underground, it's really about running a service when things aren't optimal and make sure we can do it safely. So there are lots of different definitions. So the classic way to think about resilience can kind of be defined on this graph. So on the x-axis here, you have time. Now, this can be anything from hours to tens of years, depending on what the threat is. For example, if you have a broken rail, you may be able to resolve that in a couple of hours. If you have, for example, a failing seawall, that might fail over 30 years. And here is the capacity where you can run a service. So traditionally you have a threat, you then have a period of disruption where the service capacity goes down. You then have a period of recovery where you solve the problem and the service returns back to normal, and then you hopefully go back to normal service. Now, the traditional method manages or measures the period of disruption, so how long you have disrupted people for. The other key is the loss of capacity, so how much you've lost compared to this and how long it's taken to recover. So traditionally, the railway has always tried to recover to the previous level of resilience or the previous level of service. Now, this is fine in the short term, but as we'll kind of go on to see, if we do this over and over again in the long term, it does cause you problems, because over a period of time, you see a real decrease. Now, that might not be obvious, but eventually it does cause real problems with infrastructure, and you end up with a big glut of work that you're not planning to do. So what does infrastructure need to be resilient to? Well, I've tried to come up with some key points. So the key one, and the one that's on everyone's agenda at the moment, is climate change. So we are seeing a huge change in our climatic conditions, and we need to consider not only how the infrastructure behaves in the climate we have now, how it's going to behave in the future. There's also natural hazards, so things like large bodies of water, unstable slopes. So again, we manage them now in a certain way. It's important to consider how we manage them going forwards. There's also kind of more left field things like disease. So we've all seen the effect COVID has had on the railway. That's had a real effect on its capacity, and we are still, I think, in the recovery phase of that now. So it's important to consider as a system how we can do from that. And also migration. So the way people are living their lives has really changed. So have we got a railway that's really going to survive and it can really perform to support that? There's also a number of man-made challenges. So I'll go on to talk about the pain of component failure and how we're maybe not doing as well we should be with that. And there's some good scare photos later on. There's the everlasting threat of terrorism, which is really linked to kind of ICT failure in cybercrime. So we are seeing more and more now reliance on computers to run our railways and removal of kind of the human element. So that does have lots of benefits, but that does actually have also quite a lot of risk it's imported into the infrastructure. And again, there's the change in behaviours and demand. So it's also, if we're thinking further ahead in the future, it's also key to consider the future challenges we might face. So going forwards, we're going to see a real challenge with the availability of minerals, which is likely to lead to a big challenge in food production. There's also a real difficulty with water resource and how the water table is changing and how that will change over time. And one of the big challenges is going to be how we keep a secure supply of energy that's also environmentally friendly. We're going to see huge changes to the climate, to the ecosystems that we all live in, to health and development, and likely also conflict and terrorism. So that's an awful lot to consider about how we're maintaining and how we're developing a railway and how it's going to thrive in the future. So the big one on everyone's lips at the moment is climate change. So this is how we currently manage it. So this is some stuff, painting some switch tips white to try and help with the thermal expansion of them. So I'm sure we all remember the summer of 2022. It's the hottest summer I think we've had on record. There were record rail temperatures of over 50 degrees. I think we had four reportable buckles on our patch. Yeah. So it has a real challenge, and what the predictions are saying is we are likely to see more extreme events like this more regularly. So I'll go on to talk about the projections. So we have good local predictions of temperature to 2050. But if you think about the renewals that are going in the ground now should last at least 30 years, should we not be considering how they're going to perform in the environment of 2050, not just the environment of 2023? Also, we have good models until then, but what happens after that? It's a very, very uncertain world at the moment. It's good news today to see that we had the agreement with COP18, but we had an agreement in Paris 5 years ago. Doesn't really feel like we've moved on very much from that. So from that, things like wind are much less certain than the predictions we've got for temperature. So wind is a real challenge for the railway. So not only does it blow over vegetation, it blows lots of hazards onto the line, such as trampolines, sheds, all the other wonderful things I had to deal with in my career. And also the risk it poses to OLE. So we design that at the moment for a certain wind loading. Is that enough? It's very hard to predict. And there are limits on all these projections. There's lots of assumptions in these. So are we doing enough now with changes to our design codes and kind of the methods we're doing to maintain our track to manage that? It's a good question. So these are the predictions for the mean temperature increases. So the 10th percentile on the right is the most likely situation. So this is average temperature in the summer. So within a 10 percentile, the prediction is it might rise only 1 degree. However, there is a model which relies on more assumptions that says it could rise up to 8 degrees, and that's average temperature. And it's the same in the winter. So you can see we are predicting to get warmer, and this is for 2040 to 2059, so 20 years away. It's coming. And it's the same with rainfall predictions. So again, there is a wide variety of modelling. So there is a model that says it could be quite significantly less and in some regions and quite significantly more in others. So the southeast of England in particular is predicted to get quite a lot drier. So that's also going to have a huge effect on how we manage the infrastructure. So in hot weather, all our assets behave differently. We've obviously talked about the risk to the track and track buckles. We've seen issues with OLE becoming slack. It has a real effect on earthworks as well. So it dries and potentially cracks and dries all the water out of it. And particularly on our patch, we have a real problem with soil moisture deficit. So a lot of our track, when the Navies built it, was built on clay. So over the winter, that gets wet and that swells. And in the summer, it dries. So you see a real expansion and contraction of the track bed. So this is so severe in some cases where you get a dry winter and a wet summer, or vice versa, that you see a real swelling and contraction of the track, which leads to real ride quality issues, which can result in speeds. So I think in the summer of 2022, we had a record of about 18 service affecting TSRs due to this, from Hastings to London. That had a real devastating effect on the surface. That's a very, very difficult problem to fix. And the only way really to fix it is to dig up all the track bed and relay it, which is it's just never going to happen. So we need to think smarter about how we manage that. And we need to try to develop better monitoring and kind of better maintenance techniques to try and get around that. So in the last 10 years, we've definitely seen more extreme short events occurring. And there's also a noticeable loss in seasonality. So the seasons are now a lot less reliable. So we see more hot weather in Easter and September and more kind of extreme weather events throughout the rest of the year. So track maintenance and railway maintenance has always been based with a seasonal element to it. It's very hard to predict that now, given the changes to the seasons and the changes to these extreme events. So that then makes it very difficult to prepare, which makes it a real challenge. So as I said, a good renewal should last 30 to 50 years. So the renewals we're putting in the ground now, how are they going to perform in this environment? So at the moment, we think a lot about whole life cost. So whole life cost is a good way of modelling the cost of managing the infrastructure over time. However, there are lots of things it doesn't consider, and a lot of it is used, to justify deferral of works. So there is a real theme at the moment of deferring works into kind of later control periods and later years. However, we're not really considering the kind of societal and the environmental effect of that, and it is going to end up with a big bow wave of work. So just considering these works in capital terms is very difficult, and it can cause a lot of problems. So this is on the Hastings line, just outside of Mansfield Tunnel. This is one of my first failures I dealt with in my infrastructure. So we'd had a 10-day blockade where we'd had a kind of direct fixed track renewal in the tunnel. They'd also done some drainage works on the crest of that hill. Unfortunately, this was in November. They'd laid lots of new turf above the drainage that we put in on the crest of the hill at the top. So when we had this extreme rainfall event, the first thing that happened was, because the turf hadn't had a chance to grow, it washed all into the drains. It blocked the drains at the top of the hill and then flowed all down the embankment, and we had to close the line. So we are seeing a real trend towards extreme rainfall events, so short, high intensity events. Now, a lot of our drainage isn't designed for that. When I was assistant track manager of the district line, I remember in particular when we used to get a intense rainfall event, a lot of the west of the district line, because the way it was designed, would go underwater, and the drainage just isn't designed to cope with that. So how can we consider these events when we design drainage of the future? It's going to require a lot of extra capacity to remove that amount of water, but that obviously comes with the added cost and the added size. So it's going to be very, very difficult to design something that's suitable for short intensity events and the longer intensity events we're used to. Another kind of key theme we've seen is the railway's lack of control beyond its boundaries. So, for example, here, a lot of the rain and the water came from beyond the boundaries, and we have no control of that, unfortunately. Landlords beyond have no responsibility about management of water, and we have no control of it. And the reduction of the amount of green land, so the amount of concrete we now have, has a real detrimental effect to the flow of the water. It always flows to the lowest point, which unfortunately usually is the railway. So how do we manage these risks? So this is a graph that was put together for the Thames Estuary 2100 project. So this is the project that's considering about what to do with the Thames Barrier. So the Thames Barrier was built in the 80s and was considered a good solution in the 80s, but now with the increased flow of the Thames and various other kind of environmental impacts, it's now not suitable, and we're going to have to build something similar. So it's an interesting model to think about. So the Thames Barrier model, so the blue horizontal line is your current risk. Kind of Thames Barrier approach, where we built this barrier considering that it should remove all of the flooding risk to London, took the risk back down to zero. But then over time, as the risk increases, there's also the risk of failure increases. The usual approach we take within the railway is that we do lots of smaller interventions. So, for example, think of these as track renewals, drainage renewals. So they manage the risk for a period of time, and then the work and the capacity they've added is then taken up by the change in the environment. So the debate really is it better to do one big project and then see it kind of manage it over time, or are you better off doing lots of little interventions? So there's then natural hazards. So does anyone know what that is?
Oh,
good. So I grew up just down the line in Newton Abbot. This was my first experience of the railway. It did used to be a lot worse than that. So I have been on that line with waves breaking over the train. it was also the bane of my life when I was a teenager, because whenever you made plans to meet anyone anywhere outside of Newton Abbot, you could bet that the sea would be rough and the train line would be cancelled. You'd be confined to the lights of Newton Abbot. So what do we mean by natural hazards? So large bodies of water, mainly the sea, but also things like big lakes, unstable slopes. Vegetation is now a real challenge for us. So vegetation is also something that's not been particularly well managed over the years. With the changing climate, we've now seen a real growth of vegetation, and now there is a huge work bank of vegetation that needs to be cut down. It's a particular challenge for trains that are out of gauge. For example, we have a Nissan train that comes from Germany twice a week that goes from Folkestone through the Channel Tunnel up to Stoke. We had the owner of Nissan, or someone from the Nissan board, come and present to us about how much damage we were doing to their trains, our recent leadership event. So because the train is out of gauge, we have a lot of vegetation that collides with it, and it surprised me how much damage it actually does. So I think something like 200 odd cars have been written off on that train just by it colliding with vegetation. So you can imagine the amount of refunds we've had to give them. Wildlife, in particular in vegetation, is also a real challenge. There's now a real legal responsibility to manage the wildlife there safely. So things like dormice, great crested newts now have real protection, and there are now real legal implications that a lot of the time stop you managing the vegetation effectively. So I'm sure you all remember this. So this was in the great storms of 2014. So the sea got so rough that eventually it washed away the seawall at Dawlish, which was, I think, was built by Brunel, or it was might have been a slightly later version, but it had been there for a long time. It then washed away the track, and it left us with the world's biggest slack. So Network Rail did a fantastic job of recovering it. So they built a sort of a temporary seawall using shipping containers. Then they had to completely rebuild the railway behind it. So they've now built a huge concrete containing seawall. So this has, in their mind, removed the risk. But is that going to be suitable for the sea state in 50 years? There's also the chalk cliffs and the clay cliffs behind them. So there is a real risk of landslide, which they've dealt with for a long time. So they've done a lot of cliffs stabilisation works, and they've also built a lot of covers. Anyone would like to hazard a guess about how much that's cost?
350 million.
It's a bit less than that.
If you can choose the seawall and that.
10 million.
So that was £80 million spent on that total. So that railway is fantastic. It is a real relic, and it is a real tribute to Brunel. Is it a sustainable solution? So there were several proposals about rerouting the railway, which were eventually dismissed. So the cost estimate of this was in the hundreds of millions. So if you balance that against the £80 million we've spent just on securing the cliffs, it suddenly becomes a lot more of a financial decision. So it's also worth noting the railway to Oakhampton has been reopened, and the rail, I think there is also proposals to open the railway to Tavistock. So over time, there would only have to be a short leg that would have to be built, and that would have been a lot more resilient to all these weather problems than keeping this line open. It is important to keep it open if we can, because obviously it serves all the coastal communities. It's important to tourism. But was that the right thing to do? Was that the resilient solution? I don't think it was. There's then also the effects of disease and migration. So I think we're still really yet to feel the full effects of COVID-19. We're still very much in the recovery phase. it's also a horrible thing to say, but I think in my lifetime we probably will see a similar pandemic. I think with the way nature is kind of mutating and the stress we're putting on the environment, I think it's more likely than not that we will see a kind of an almost game-changing disease, which is a horrible thing to say, but I think looking cold, it is quite likely. So since COVID, we've seen a rise in kind of longer, less frequent commutes. So people generally now come to the office 3 days a week. And there was a real trend during COVID of people moving further away. So the metro railway we have was designed to get lots of people into London in the morning and lots of people out of London in the afternoon. Now, Monday and Friday, that's no longer a challenge because they're like ghost trains. So that change in demand has led to changes in maintenance. So we're now considering things for the first time, like daytime closures during the day when the railway's not being used. There's even areas of the country that are considering engineering works on a Monday because that has become the lowest day of demand and people are a lot more keen to use the railway for leisure than they are for commuting. So that's obviously been a real step change in how our users have used the railway. How are we going to prepare for the next one? Because there will be change again. So what can we do to improve resilience? Well, there's two real approaches. So you've got your hard approach, which is going and doing physical works. So this is things like engineered defences, so building more capacity into your drainage, that kind of thing. So that works really well for new works. We have a lot of tunnels and a lot of infrastructure that's almost over 200 years old. Very, very expensive to do it to a 200-year-old tunnel versus putting something new in the ground. So it's really important to consider through the design phase. So can we build in extra redundancy without making it crippling financially? And can we consider resistance where possible? So this is really important with things like flooding. So can we avoid putting anything in a floodplain? Can we avoid the risk of that? As I've talked about as well, investment in maintenance activity is important. So I think the resurrection of kind of the management of off-track and drainage gangs has seen a real improvement about how we manage this. And also investment in relevant research. So a lot of railway technology is very old. There's lots that can be improved in it, and I think it's important we look ahead to that. Then there's a soft approach. So in my opinion, this is really learning to understand the problem better. So there's technological elements of this, so e.g. better weather forecasts, more reliable forecasting. That then improves your understanding and communication of your infrastructure. So if you understand the problems with your infrastructure more, you can come up with more efficient solutions and you can communicate to the users when we don't think it's going to be able to work. So we are slowly getting better at this. It is still a problem. Investment in training, again, is key. So making sure your workforce has the correct skills and learning from your mistakes. Jonathan Graham gave a really good talk last month about how he's seeing a real repeat of a lot of the really tragic and big rail disasters happening again. We've seen it in Network Rail recently. Are we learning from our mistakes? I think a lot of the time, I'm not sure we do. So a good example of this is Baker Street Station. So this was a picture of Baker Street Station when it first opened. I've always had a soft spot for Baker Street because when you go down there now, it really hasn't changed very much. So a tunnel that was built for steam trains and was built for a far lower passenger demand now hosts an S-stop train, which is probably twice the size, that drives itself and is still suitable for modern demands. So how did the Victorians know that was going to be suitable? Did they think about it? Did Brunel ever think about design life? A lot of Brunel's infrastructure is almost 200 years old and it's still going. A lot of the things we put in the ground now have a really short design life. So it's a really interesting point to think about. Did the Victorians have more of a vision of this than we do now? Or was it by pure luck? So this is a picture of the Thames Tunnel, which Brunel's father and him built. So it's now part of the London Overground that goes under the Thames. So as engineers, we are fantastic at solving problems. Designing new assets when you consider resilience is very easy. It's much, much harder to consider when you have existing assets that are already, in some cases, centuries old. So we need to build capacity and understanding in the kind of short-term world. So in Network Rail, we have control periods. So we have 5 years of guaranteed funding. There are other railways I've worked with where we've had much less than that. So it's very hard to plan for the future and build in resiliency when you only have a budget till the end of the week. So obviously economics is key to the efficient running of a railway, but it's very difficult to reflect the true whole life cost in this. And when you consider in things like resiliency at the start, it's often kind of engineered out as cost savings. So it's very, very difficult to justify. But are we considering the cost over its full life? I don't think we're very good at that at the moment. So then there's also the man-made challenges, as I discussed. So the key challenge for any maintainer is component failure. So these are photos from 2 cast crossings we've had break at the Tri-Metal Zone. So these were both this year. So the bottom one was at Long Edge, which is in South London. So this happened on Valentine's night. That was only detected when we had the signalling go down and as a signal failure. The top one happened last week. So this happened on Wednesday, a week ago. So this was going into Stewart's Lane Depot, where GTR keeps all its fleet. It's also the key route for our £8 million Voltaire Road renewal, which is happening over Christmas. I mean, Justin have been frantically running around trying to find a new crossing for that. So the key really when you have component failures is still being able to run a service when things go bang. So with a lot of railway components, they are very resilient. There's lots of temporary repairs you can do. As a maintainer, we really struggle with cast crossings. So cast crossings are fantastic when they're installed. They're fantastic throughout their life. When they go bang with little or no warning, they are incredibly difficult to replace. So if you have a spare, which is generally not the practice now, you need an RRV and an army of men to install it, whilst with a fabricated crossing previously, you only needed a couple of iron horses and 4 or 5 staff. If you don't have one, lead time's 18 weeks, generally. I don't think the public are accepting of having a railway closed for 18 weeks. So generally components like this are designed for whole life, so we have to replace them. There's a real point of failure in the Tri-Metal Zone, which we've kind of experienced a few times this year, and we think it's a growing trend. It is impossible to have a spare for every crossing. We simply don't have the space or the capacity to store them. There's no signs or measures of fatigue. Generally, they just go bang. So this is the scary part. So this was known as the Utley joint. So the supervisor that put it in was so proud of it, he wanted to name it. So what we had to do in this circumstance was we had to cut out the Tri-Metal Zone where the rail had broken, butt up a plain rail to it, and then put this rather exotic clamping system in place. So this is 2 plates secured by a clamp at one end. To give it some stability, we put an old sleeper under the other end and we secured it with some pins. This is the level of kind of first principle engineers we've had to go to just to reopen the railway. So what do you think it looks like under load? You might be pleasantly surprised.
Need to improve your fixings. Does that say outro?
Bit better than G fence.
Yeah.
Does that say U-tray on there?
Yeah, I think it does.
Yeah. Okay, that's a known failure.
So this was taken by a new trackside camera we're trialling, which detects movement of every train, so you can monitor it without being on site live, which I think is very impressive. So for such a Heath Robinson solution, I think that worked pretty well. We still had to live with a speed of 5 miles an hour, and we agreed we'd check the clamps under a line block after every train. But it did get the service back up and running. But should we be having to consider solutions like that with such modern componentry? So maintainability is often really neglected during the design stage. It's very hard to consider, and it generally, as I said, is engineered out as a kind of a cost saving at the start of the project. It's also worth noting, I did a 4-year Master's Civil Engineering degree. I must have had 400 or 500 hours of lectures every year. I don't think I had a single hour on how to maintain anything. It was all about construction, and it was all about new works. We have very, very little formal education in the UK about how to maintain things, which is kind of mad when you think about it, about how much existing infrastructure we have. So I only really learned to start maintaining infrastructure when I went to work for Tom on the Piccadilly line. So that it's really not a well considered fact, I don't think, throughout the whole design life of infrastructure. So flexibility is key. So as you've seen there with the cast crossing, we were kind of left with that solution, which did allow us to run a service, but it had a massive effect on the capacity until we could replace the crossing. We really need to be considering at the start of the project and as part of any design, if it goes wrong, can we fix it with the existing tools we've got, or what do we need to put in place to try and help us fix it? So this is where relevant research to improve asset life is really important. So there is lots of work going on, and I've been involved in a number of trials of exotic rail technologies, some of which have been successful and some of which haven't. It's also key to learn from your mistakes. We have no capacity in Network Rail to manufacture fabricated crossings anymore. We are completely reliant on suppliers. So thankfully, for the one that happened last week, we managed to get LU to build as a fabricated crossing. So Howard saves the day again. But that is quite a scary fact that we don't have any capacity to do this. I think we were quoted April for a cast crossing, and was it September for a fabricated one, Justin?
June.
June 2024. So it would take a supplier longer to manufacture.
San Diego flooded isn't helping
Yeah,
things like
that
that.
doesn't help.
Resilience.
So it's key to think about the cost of making these changes at the design stage versus the construction stage. There's also a real consideration now of terrorism and cybercrime. Does anyone know where that is? So that's the Highgate Control Centre on the Northern Line. So that was opened, designed and opened shortly after the 7/7 bombings in the early 2000s. So there was a real fear of kind of more attacks on infrastructure then. So it was built with that in mind, and that was the real overriding consideration. So one thing to consider is to what extent can you design out the risk of terrorism? Now, you're never going to design your infrastructure to withstand sort of what you consider from previous infrastructure attacks, such as 9/11 or bombs. But what can we do to try and reduce the risk of these things happening? What can we do with existing infrastructure? That's even more difficult. We have lots of 200-year-old tunnels and earthworks. We're also now increasingly computer controlled. So are we adapting our approach to address this? It's a very difficult problem. I think anyone that managed to hack our filing system would struggle to find anything because it's so archaic. But there is a lot of sensitive information, and there is a lot that can be gained by someone who maybe has the wrong motivation by accessing these things. So a big trend now is driverless trains. So the DLR, for example, drives itself. It has a guard. We now have the automatic signalling on the underground. Is this practical in light of this risk? Do we need to think about other things to control it? So then there's also changes in behaviour and demand. So again, as I said, we've kind of seen almost an end to rush hour, and we now see a more constant demand, particularly at weekends, for leisure and travel. Track access now has really become the limiting factor for maintenance. It is a real challenge. So more and more operators want to run more and more services, and particularly at night is a real challenge. So there are trains being planned later and later, and we've seen the introduction of night tube on the underground. How does this balance out versus the time the maintainer needs to maintain the track, maintain the infrastructure? And we've obviously seen the cancelling of HS2 north of Birmingham. How are we now, if there is any future capacity requirement, how are we going to consider the increase? It's going to be very, very difficult because our existing infrastructure is at capacity. So the current key guidance now is ISO 14090, which is all about adaptation to climate change. This was released a couple of years ago. So it's designed for any organisation to try and adapt their approach to climate change. So if you run a cricket club, if you run a football club, or if you run a railway, it gives you different levels of advice. So again, it emphasises the importance of thinking as a system rather than about individual assets, and thinking about how the different assets interact with one another. And there's real guidance on adaptive capacity and kind of dealing with the uncertainty of climate change and trying to develop a better understanding of climate change. So how can we improve? So I don't know how many people who are here are fans of Formula One. So Formula One's obviously a very technical sport. They have very high-tech cars that are highly monitored. So they monitor something like 12,000 different individual things about the car. The engineers that sit on the pit wall, I think, only look at something like 40 of them. So there is a lot of monitoring, and that has given them a lot of better understanding of the cars. They've also managed to develop a lot of predictive tools, which gives them a lot better understanding of how to win the race and what are the deciding factors. So that tells them when to change, when to have a pit stop, how much fuel to put on, that sort of thing. So having that data before and having that knowledge of your asset has really helped kind of make those cars such high performance. That's a real approach that I think the railway could adopt. So the real key, I think, is better understanding of the problem. So effective key monitoring and being able to process the amount of data we generate. So there is a huge amount of data we already collect. We're reasonably good at processing it now, but it is a real challenge to get it to a state where we can recognise when it's saying we've got a problem. And there's also generally very poor historical records kept. So most infrastructure failures are generally repeats. It might be over a few days, or it might be over 5-10 years. We have nothing at the moment that says this happened 10 years ago and this is what we did, this is what fixed it, this is likely the problem. So the key then is to use this to try and update our guidance and our standards to make sure that they are kind of reflective of the current state and the kind of predicted state we're going to go in. And also we're beginning to see a lot more use of automation and the use of AI. So Formula One teams use what's called Monte Carlo modelling, where they change lots of the different parameters about the race, and that then gives them a prediction about what's going to happen. So I think that would be a really powerful tool for the railway. So that could then tell you if you have a failure of a certain asset in a certain place, what's the best way to recover from it through modelling. So we also need to have kind of develop a better understanding of the interdependencies of all the different systems and what we should be doing and what has the most benefit, so we can prioritise the best work to do. And again, kind of key from learning from mistakes, we need to address what currently doesn't work, learn from the mistakes. So someone has come up with a model for the railway. So in their mind, there are 7 different subsystems within a railway environment. So at the top there, you have the different kind of people who control it from a high level. So the TOCs, the management companies, and the ORR. So kind of to the right of that, you then have the financial element of who funds it. Then you have sort of the element of ticketing and how that works and how that interlaces. The kind of green or eye-shaped one in the middle is all about your infrastructure and the people who use it. Then to the left here, you have all your hazards. And finally, at the bottom, there's more about how infrastructure management. So all the different arrows show all the different dependencies. So I'm sure you're confused as I am looking at that. It's really hard to understand what has an effect on what, and I don't think we really have a good understanding of that yet. So developing that is key. So if we think about the financial challenges, so future generations are going to need to pick up the cost of 200 years of industrialisation. So do our current investment rules reflect this? How can we drive the right long-term decisions that I've talked about in a short-term investment environment? And how can we change our performance metrics to reflect this? So in Network Rail, we use delay minutes. Delay minutes generally has no reflection on how many people are on the train and the other kind of effects it's had. Finally, don't forget about the extraterrestrial challenges. So this was an article in the paper this week. So there's been some research done that thinks that the increase in solar storms could have a real detrimental effect on railway signalling. We could see the change of aspects due to solar flares. So there's always things from the left field you've got to worry about as well. I think that's unlikely, and you can imagine the tabloids enjoyed that one. But it's always something to consider. So, do you think we're doing enough to ensure that future generations will have a railway fit for these challenges? I'd like to open that to the floor.
Thanks, Tom. Tom, let's throw a couple at you of people effectively trying to make things worse. One of them, Network Rail, has actually done work on to stop it happening. But going back about 20 years, there was a new approach. It must have been the time Eurocodes were coming in, that sort of thing, for structures design. And there was a session at the ICE on the new guidance, the new design codes and whatever. And I commented about the fact that for bridges, it didn't deal with making sure they didn't become roosts for pigeons. And it was interesting because the designers didn't think it was their job. There was quite a violent verbal pushback from bridge designers. You know, that's not our problem. Well, of course, it is their problem. It is a problem they are creating. I mean, Network Rail's design standards now very much include that as a feature to design out for structures, which is good because, you know, the message has obviously got across. It's a major problem. But on a light rail project I was involved in, the council's environmental people were keen that a couple of bridges over watercourses, these brand new bridges, actually had built-in bat boxes to allow bat roosts. And the project people were looking to go along with it. But myself, looking at it as the independent safety person and the council's person, because one of the bridges would remain the council's engineering people, we both went ballistic because we said, look, you cannot disturb bats, but these structures you're going to have to go under once a year just to do a visual, once every 5 years to do an actual intrusive in going into it, and potentially once every 20 years, you're changing the bearings, but you're deliberately building in the least disturbable animal possible. What is going on? But the project, of course, who's only interested in delivering, And it took me, with a background in maintenance on the for the bridge that was going to be part of the light rail, owned by the light rail system, and the council's engineering people who are going to be responsible for the bridge over their watercourse, to push back to say, no, this is absolutely bonkers. And, you know, this is the inverse of resilience, because people are not prepared to push back and say the good one is on Pigeons, Network Rail has. But on the bats, it took two of us to stand up and just say, no, this is not, this is going to make this virtually unmaintainable.
So this is very similar to the issue we have of off track at the moment, in that there are lots of protected species now that live in the area around the railway, and they're now so legally protected. We've been threatened with prosecution for taking down vegetation that could potentially block the line and potentially cause quite a big accident. So it is a real balance, and we need some kind of common sense approach in that, rather than should they be there in the first place.
And you've got the contrast in that between the rabbits that you have to manage in one way,
Yep.
and badgers that are managed in a different way, and you have to work out what's living in that particular hole.
Yeah, which is very difficult a lot of the time.
Stuart's got his hand up online. So maybe.
Thank you. If a bad railway means more cars, or more car journeys, which it very likely will, it gets worse emissions, and all the bad that will come as a result of that. As a society, we can't afford not to do a good job of maintaining a resilient railway, but we aren't doing it. Do you have any ideas what the root cause of this is?
Sorry, Tom, can I come in on on Stuart's point? Like Stuart said, we're not building. If we build the railway to a good specification, how it should be, is that acceptably resilient? I used the example of your flooding near the tunnel. Now, there were a number of issues there that then led to the flooding, didn't there? But if that was preventable, so there's an argument, was it a climatic thing, or was it just, you know, and I know there was a bit of bad luck that you had heavy rainfall after putting in new turf, but
yeah, I mean, it was in the season where you'd expect heavy rainfall.
Exactly.
Was that a wise decision? Probably not.
How much is it a case of let's do things what we know and do them well, and that'll be as resilient as we can do? Or do you think, as Stuart suggested, we can do a bit more?
I think we can definitely do better. So I think part of it is caused by the funding situation the railway currently has. So we're quite fortunate in Network Rail, we have 5 years of guaranteed funding where we can really accurately predict what we can do, and we can have confidence that we can deliver that. In a lot of other railways, it's a lot less certain, so it's very hard to make good long-term decisions in such a short-term economic environment. Yeah. There's also a lot of barriers for trials for new technology and new infrastructure, which I think puts a lot of people off the railways and doing it. It's there for very good reason, for safety reasons a lot of the time, but it is often prohibitive for doing it. So I don't think that helps. I think also it's kind of repeating the same mistakes and not learning from your mistakes and not being willing to change your approach. So we are seeing a very rapidly changing world. We're maybe not changing as quickly as we should do to try and make that effective for the way we maintain and build the railway. So I think they're the three real main causes.
And just a challenge, because you showed those broken rails, and there's been a spate of broken rails, but that was because of a cold snap we had. So, you know, you have the summer of 22 when you've got buckles, but you know, when you get a cold snap, you get tension in the rail.
Exactly,
well,
so different season.
Works both ways, doesn't it? It's difficult.
Yeah, absolutely.
Yeah. I was actually heading towards the route as well. If the funding situation is bad, why is it bad?
That's a good question. So I think in the short term, COVID obviously was devastating to the industry, and it kind of destroyed the funding model we have. Longer term, that's a very good question.
sorry to come on Stuart's point. Sorry, Stuart. I feel like I'm sort of. But we say money's a problem, but then you showed that Dawlish 80 million quid on a. So funding, if I was other countries, I would look and say, well, you can't be too hard up,
So that really poses the question around how good are our financial controls around our projects at the start. So are we really looking at kind of cost and benefit?
All projects, I think you're right, Tom. All projects are being asked to deliver minimum viable product.
Yeah, MVP.
And the problem with MVP is they say it's considering the whole life. It's not considering resilient change. It's just a 5-year. Let's do what we can with the money in 5 years.
Exactly.
So there's loads of things we could do to track to make it resilient, and we've got some really good ideas, but no one wants to pay for them.
Yeah.
And we can change standards, but look, we can't afford that change because it means our unit rate for track renewals goes from 1750 to 2,800. It means you need to pay. Because otherwise we won't have a 50-year railway, we'll have a 20-year railway.
Exactly.
Yeah.
But the real question is, how do we change that? So do we?
It's changing minds.
Yeah.
And I think going to the people that control the money for each region, so you go to these groups and you say to people, right, we're about to change, we're mandating under sleeper pads, for example. This is one, what's the reason? It gives us better climate resilience because it's not likely to buckle, because it's got better lateral resistance, it protects the ballast, it protects the whole life cost. Why aren't we doing it? It's an extra 1.2% of the unit rate cost. It's a no-brainer. Why aren't we doing it? We can't afford it. Well, it means you do 1.5 less track renewals, but the track we do put in is going to last longer.
Exactly.
That should be a no-brainer.
Yeah, it should be a no-brainer. But there are people stopping that because they think it's too expensive.
So the kind of question then is, why aren't they listening?
And I think what we have to do is just mandate it and make it happen. We have to, at top, so Andrew Haynes's level and people like that need to say, sorry, stop this. It's going to be mandated for climate reasons and resilient reasons. Otherwise, the decisions people are making at that, purse strings, level are the wrong decisions.
And that is what is dominant.
Yeah, and regions have their own little idea of what they think is good as well. Yeah.
I think one of the things about society is we've increasingly gone into disposables. So you buy something, instead of trying to learn how to maintain it, you just dispose it and replace it. Yeah. And for me, that's why in academia, there is very little emphasis on maintenance. You just redesign something new, swap it in and swap it out. Okay. There's two things wrong with that, in my opinion. One is we're using up materials and minerals that are increasingly getting scarce. Yeah. And second of all, we've lost the vision the Victorians had, whether they generated by accident or not, because they built fundamentally infrastructure that stood the test of time. I'm not so sure modern infrastructure does.
No, I don't think it does, because Brunel would never thought that. Brunel was building a railway to be there forever.
Yeah. So I think
you can argue with that was the right.
I think there needs to be a change even in society and how we look at that.
That's a good point.
Yeah. Tom, I think there's also a political dimension to this, because I'll stick the knife into politicians. It's something we all love doing, but hey, they take the money. So, to my mind, and this is just my personal view, politicians love a project, okay, because they can make a big announcement in the House. So we've allocated so many millions, billions, whatever to this project, and then, generally speaking, they get to open projects that someone else started, but they get to go there and cut the tape and shake hands and all that stuff. So they love a project, Maintenance ain't like that, as you all know, right? And you made a very good point. Didn't think you made it forcibly enough that most of the infrastructure, we've already got that, yeah? And therefore, that needs to be looked after.
Yeah.
Because it's not fit and forget. It's built-in infrastructure. So I agree with Sean's point. Disposable commodities are the bane of modern society, but you can't do that with infrastructure because it's physically present. So there's a political dimension. Politicians love a project. Maintenance is not like that. And somehow that is another message that needs to be shoved into the politicians and into the senior levels of management and into the people who hold the purse strings. You've already got it. It wears out. It's not fit to forget. It needs to be maintained. If you want to maintain it at this level, so you can have this amount of service running on it, this is what it's going to cost.
We're very bad at making that argument. I would agree with that.
I think it somehow needs to be made better, but I don't know how.
I always try to sell maintenance to kind of younger people coming into the industry. Is it the everlasting project? So you're always going to have funding. You know, you're always going to have work every year.
Steady work.
Exactly.
Yeah, steady work, that's for sure. Yeah.
So maybe we could do a better job of selling that higher up. I don't know, but it is a real challenge.
To my mind, it's the most important job.
Yeah.
Yeah, because I've been on major projects. Yeah, and I loved it. Yeah, it was great. But it's the people who maintain it that keep it going, keep it safe. That's where the real important roles are, in my humble opinion.
I think you were talking about innovation.
Yes.
And R&DI. So the R&DI budget has been cut by 38% or something like that. Gareth Evans declared the other week at the PWI renewal seminar. But we're not doing enough in that innovation and our RD&I work within maintenance. A lot of it in capital delivery, like Mike says, all the spends in the shiny projects. And you're right about monitoring. There's a lot of, the II project, intelligent infrastructure and so on. That a load of that money just got taken away because they said there should be business as usual. You should be adapting to those new monitoring processes and stuff. But a load more work is still needed on that. And I think the lack of investment in innovation in some of those systems for maintaining a safer railway for the future and a resilient railway have gone now. And I think you guys should have a better say in what should be innovated, what should be, taken forward and spent money on, because it gives you a benefit as a asset custodian as well. But and there is a lack in that.
We do already have a big capacity for intelligent infrastructure, as you said.
Yeah.
There's no memory in it. That's kind of what kills me.
Yeah.
In that, as I said, most failures are either one thing or another. If we were to be able to build that into a kind of an AI program that could tell you it's probably this, that'd be really powerful. And that, I don't think that we're not far away from that.
Yeah. Still, too much data, not enough analytics, and
Mike.
Might be held up.
Two more.
So you said the word memory there, Tom, and in your presentation you spoke about memory of past events.
Yeah.
And as you said, John Graham did a presentation to the London Section about that last month. Very good. It's an issue that I've heard discussed once in a while about loss of corporate memory. The people who live through those incidents, because they're fatalities, but the people who worked on the railway, experienced those incidents, would never have forgotten them through their working life.
Absolutely.
Yeah? And there's a need to somehow convey that to future generations. I don't know what that is, but is there a need for a book to be published, or
that is one of the big
page on the PWI website saying, look, if you want to know something about you should, these are the things you need to know about. This is where these regulations came from.
Yeah. So there is I fully agree with you. We have had some challenges recently in Network Rail where we've had to kind of start to think about that. And I think understanding, as Jonathan Graham said, understanding why we do things rather than just what we're doing is really important. We have a very young workforce now. So unfortunately, we have lost a lot of the more senior people in maintenance, and a lot of the people coming through the ranks are apprentices. So they kind of have very good knowledge of how things are written in the books. They don't have a lot of on the kind of boots on ballast experience. So conveying that to them and making them understand it is a real challenge. So I remember growing up, just when I was I can remember things like Potter's Bar and Hatfield being on the news and being quite scared. because I mean, my life was kind of dominated by the railway in Devon, because that was the only way we could get around. But I think people growing up now don't have any exposure to that, so get them to understand that. I mean, we've just passed the anniversary of Clapham.
Yeah.
So of course it was done for that, but I think we have seen situations similar to Clapham relatively recently in Network Rail that weren't fatal, but could have been. So it's how we can get people to understand why they do what they do rather than just what they're doing.
Some things have been engineered out, obviously, as a result of those incidents.
Yeah.
But there are some things that happened in those incidents that can't be engineered out.
Yeah.
And they're the ones that need to be passed on.
Fully agree with
I'll shut up.
you. Well, go on, John.
Yeah, it's an operations point which has implications for infrastructure. In that there's been a number of recent things appeared on the RAIB website about train drivers going through TSRs too fast and problems with that. And I was surprised to learn a few years ago that these days there aren't things like late notice cases. I mean, I was brought up where every train crew booking on point had a case with a red surround on the box, the case, and that was something that the drivers would all look at when they booked on and wrote notes down. But apparently most TOCs don't do that, and Fox particularly don't do that, because a lot of people are booking on online now. So there's, there is the issue. It's not, if you like, an immediate thing that the drivers always did as part of the process, was going to the late notice case to pick things up that weren't in the weekly notice and that sort of thing. Yeah. Because when you look at the rave ones, it's not something that's been put on particularly when the driver was on duty. They were the drivers who booked on after it was imposed. So obviously people feel that the systems have improved because people have been booking on online and that sort of thing. But you've lost something that was effectively a cheap way of making sure that people knew what was going on.
Yes. Which
was because even at depots that didn't have a train crew supervisor, it was normally the state, like say Horsham or somewhere like that, where there were limited number of drivers. There was still a red case, but it was the responsibility of the station staff then to look after it. And it was the station staff who confirmed that the driver was not looking under the weather in whichever way as well. So there was a physical check on the driver before they got on.
Yeah.
Which, particularly with the freight drivers now doing completely things online, it's just that these sort of cutouts of things seem to have disappeared.
Yeah, it's a very good point. It's a lot of resiliency is about communication. So if we're not communicating the right information to the right people, we've failed really as operators and maintainers. So that is a worrying trend. It's worrying that they can't build that into an online booking system.
And of course, the other one that used to happen in the old days is if you put an emergency speed on, you'd have somebody out there shooting it.
Yes. Go on, Darren.
One thing talk about corporate memory and forgetting things. So the Utrey crossing you showed there, in 2015, there was a spate of TMZ failures, and they went out to France to the factories, just Network Rail, the welding guys and the rail metallurgists at the time, because there was a QA issue over the finishing of the TMZ weld on Utrey crossings, and it was a problem, and there were a spate of failures. I wonder if we forgot that. I don't know, but there should have been a raise. By the way, TMZs on Utrey crossings are a higher risk than others due to a QA failing. Keep an eye out for it. And I think what you did there with that plate was brilliant. You had to get around it and you made it work, and it's a shame it wasn't designed into the process. If it does fail, do this. And a similar thing happened on Vanguard at Thameslink. They had a cracked rail. they couldn't put a temporary clamp on there, a joint on there, because there's no room
No, exactly.
between the blocks. Yeah, you can't physically put a plate. So someone cut a fish plate down, made it fit, and it worked.
Yeah.
So then it came back, can we now have a design that works with Vanguard that we can put a temporary joint on if we do get a rail break, you know? And the same with your crossing, can we have a design in case that fails? So I think we need to design better resilience in some of those assets, be it new or legacy.
Yeah,
So you've got those tools in the bag.
And it's never going to be practical to give a new crossing with every crossing we've put in as a part of a project.
And the guy that did that, you know, fair play to him. He obviously, you know, came up with that solution. But if it was there ready for him, he could have got it done a lot quicker, or they could have got it a lot quicker.
I mean, could you manufacture some plates that could do that?
Yeah.
That'd be a lot cheaper.
I think ingenuity is exactly, and maybe wrong.
Exactly.
Come back to your question about vegetation, Tom. What happens with vegetation in the future?
Very good.
You were
question.
concerned about the fact that vegetation was more prone, causing more problems with the heavy rainfall.
So
Where do we go?
the big challenge we have at the moment is we're still reliant on manpower to cut it down. So we don't really have any mechanised kind of methods of removing it. So with kind of the more extreme climate we're seeing, so we see more extreme rainfall, more extreme heat, which causes more growing. The growing season this year, because we had a warm spring and then a wet summer, was terrible. So we need a more kind of mechanised method of removing it.
Nissan cars.
Well, they're not that keen on
Blades
that,
on
to
the
be honest.
side.
They're not that pleased with that. We are.
But flails were never very popular with external people. You know, I mean, that was a fairly brutal way of cutting down, of cutting through. But the number of angry people it created. Do you use flails still?
We don't know. With the times we get generally in possessions, by the time we've set that up, you have to take it down again. It's really not an effective method we have at the moment. So we've seen trains now that can lay track. I don't see why we can't develop trains that can take down trees.
There is a drone. They're looking at a drone that can cut trees.
We're actually going to trial, funny enough you say that, we're trialling a helicopter that has 3 saws underneath it, like on James Bond.
Yes.
Come along to that.
That's a BMW in half.
Okay, sorry, I'm going to have to sort of step in there because time's pressing on. But I think, given the lively nature of the debate, there is an indication of sort of interest in the subject. So, on behalf of everybody here, sort of want to thank you for an interesting and a challenging talk. And it's very nice because obviously Tom's one of the members of the London section. And a quick plug: if anybody in the audience has a paper or know of people that would like to present to the PWI London section, do let myself or one of the other members of the committee know. But Tom, yeah, it's very, very topical. I mean, you mentioned COP18 and of course all the media attention that was getting. I like the way that you started off with a little reminder of resilience and it's about the system. I think you mentioned fence line to fence line. So don't just think about the assets, think about how they operate together. And a useful reminder on drainage and soil slopes and the like that perhaps have been neglected, but also one that came up again in our discussions, and that's resilience of organisations, which is perhaps the sort of softer side.
Yeah.
You mentioned something about the future challenges, and you was into modelling, and then the sort of some of the whizzy stuff that you showed us in Formula One. I quite like that, and the idea of you getting a bus load for us, we're all going to go and visit Monte Carlo. That definitely grabbed my attention. So thank you for that. And also a little bit about some of the improvements. So obviously there's the hard improvement stuff, the engineering that we all like, go and rebuild the seawall or whatever it is, but also the soft stuff. And we mentioned the importance of things like research and the role that has to play and just being smarter in how we do it. Because a lot of the stuff's it's there. We're not going to change it. In the words of Basil Fawlty, that's it. We're stuck with it. So we've just got to manage it better. So on that note, I think I'd like to just ask everybody to join with me again and thank you in the usual way. So thank you.
Right, next meeting, I think scheduled for January. I think it's
10th.
10th. And hopefully we'll have our PWI president for that one.
Fingers crossed.
Yeah. If not, we're trying to dial him in from in the ether somewhere, I think. Okay, I think someone might be going off to one of the local hostelries. Mr. Barlow will be leading the way to the local hostelry afterwards. And thank you very much for.
So I'm employing.